A simple harmonic oscillator has an equation of velocity in meters per second of v is 1.25 cos 5.60 t. All right, so let's take a look at this. We know, here's what we know. We can do some careful sleuthing, because remember the formula, there's two formulas, right? Okay, that we can do with this, right? And the corresponding x formula for this is that it's x naught. Here, let's just write them together here. X is x naught sine omega t, right? And then corresponding to that is that it's omega x naught, and then this is cos omega t. Okay, so if this is our velocity equation, this would be our x equation. Okay, from this we know that that is omega x naught, and that's because I'm just looking at the equation, right? Where omega x naught is, we've got the number 1.25, right? And then we also know that the omega is that's omega. Okay, so just doing a little sleuthing here. Okay, we know that omega is 5.60 radians per second, and then we know that omega times x naught is 1.25. Okay, now using some devilry called division, okay, I know that x naught is equal to, I don't know if this is going to be useful, right? But x naught is just going to be this divided by this. Is that right? I think so. Yeah, because this, yeah. 1.25 divided by 5.6. So x naught is 0.2232 meters. And this is, what is this going to be? This is meters per second. Okay. Is that going to be useful? I don't know. I think so. Okay. So what is its position, velocity, and acceleration at t is equal to 4.6 seconds? Okay. We can do this. Now you have to make sure that you are in radians. Okay, so make sure your calculator's in radians. Go hit the mode button. Are you in radians or not? All right, I am in radians. Okay, so my x is going to be x naught sine omega t. And I just figured out that my x is that, right? So that equals 0.2232, okay, times sine of 5.6 times, what's our time? 4.6 seconds. I can do this. Okay, times sine 5.6 times 4.6. Is that right? Yeah. And I'm getting 0, it's positive 0.1310, something like that, meters, right? Ta-da, all right. That is my first one. What is its period? Oh, we never found out its period. Okay, we can do that though, right? The period. Save our space here, right? I'm going to use the fact that omega is 2 pi over t, right? So therefore t is 2 pi over omega is 2 pi divided by 5.6. Let's do that. Let's see, 2 pi divided by 5.6. It'll be a little more than 1, right? 1.21 seconds. Oh, 1.12. Dear Lord. My calculator does say 1.12. All right. So we did that. Now we've gotten that period. We've gotten what is its position? Okay. So now let's figure out the velocity, right? The velocity is going to be, we can just use that formula, right? V is 1.25 cos 5.6 times, and then 4.6 is our time, right? Times cos of 5.6 times 4.6. And that is it's positive 1.01 meters per second. Okay, so these are vectors, right? Any number that comes out of these things is going to be positive or negative, however is appropriate, okay? That's why I'm overtly labeling these positive, right? And then what's our acceleration? Our acceleration is the opposite of omega squared times x, right? So this is our x. We're going to plug that in, right? So that is the opposite of 5.6 squared times 0.1310106. I'm going to use that unrounded value, right? So the opposite of 5.6 squared times, and I'm going to go up arrow, grab that number. And I get that it's negative 4.108 meters per second squared. Now, my units are going to come from here. This is meters, and this is radians per second. Squared is going to be 1 over seconds squared, and there it is, right? And meters is that. Okay, so 4.11, yeah, that makes sense. The fact that we are at a positive displacement, right? If you just draw a picture of this thing, right? Here's 0, here's a positive x naught, here's negative x naught, right? The fact that we are at a positive displacement, let's see, what is our x naught? We are about here, okay? The fact that we're here means that we're accelerating to the left, okay? Anywhere to the right of this 0, we're accelerating to the left. All right.